Hello. Oh. Hello everyone. So guys, am I audible and visible to you? Hi, good afternoon Senapati. How are you, Shillong? So guys, what's going on? Please share your attendance on the portal. And please tell me the topic that we were discussing in the previous class. I guess so. I have asked about the attendance. Just I think 3-4 minutes before, I have asked you that, am I audible to you or not? Shillong, is everything going on fine? How many students are there at the Shillong and the Senapati Center? And please share the topic that we were discussing in the previous class so that we can start. Okay. Okay. And what was the topic? Okay, photoelectric effect. So, okay, so all the students are in the class or still some students are outside? Can I start? If everyone has joined the class? Okay, yeah, you can do these symbols, okay, your typical symbols. I'm able to understand that. Is everyone ready? Oh. So guys, let's begin with the photoelectric effect. I think so I have given you a brief idea regarding the photoelectric effect, and we were at the point where we were discussing about that kinetic energy would be equals to E minus phi, where phi was the work function or the threshold energy. Okay, so first of all, we will write its definition. Work function, or this is also known as threshold energy. So we can define this in this manner, that the minimum energy that is required to just eject the electron from the surface of the metal. This is your the minimum energy required to just eject the electron from metal surface. Copy please. Done? Okay. Only one student has copied that. Okay, yeah, very good. Where is Nefi? Where is she? Yeah. So dear, please copy this. Stop using your phone. Okay. So guys, let's move on. This is the threshold energy. Now, next. Threshold frequency. So this is represented by the nu naught. Okay. Please copy this definition as well. The minimum frequency required to just eject the electron from metal surface. Okay. Next is threshold wavelength. Which is lambda naught. This is the maximum wavelength required to just eject the electron from metal surface. Copy please. And guys, what about the status of the sheet? How many of you are practicing that sheet? Because in the next class, I'm going to arrange doubt session of the sheet. Copied? Senapati, have you done that? Have you copied that? Okay. Shillong? Okay. So guys, let's move on. So we were discussing about this one, that kinetic energy, one second, is equals to E minus phi. Now tell me, how many of you are clear with this term that kinetic energy should be equals to E minus phi? That this is a right statement. Senapati, Shillong. Okay, so let's understand this statement, that how kinetic energy should be equals to E minus phi. Okay, so guys, look at this. This is your metal surface, and here electron is moving. Okay, let's say suppose the work function of the metal surface is 500 joule. Please do not copy this. This is 500 joule. Okay, it means that if you supply the 500 joule energy to this electron which is moving in this direction, okay, it will come to the metal surface. Okay, if you supply 500 joule of energy, it will come to the metal surface. Okay, now this is the energy supplied by you. Okay, so let's say suppose you have supplied the energy of 800 joule. So what will happen over here, that out of 800 joules, the 500 joules of energy has been used by the electron to just come at the surface of the metal surface. Okay, when electron reaches at the metal surface, it has already used total of 500 joule of energy. Now the question is, how much energy is left to the electron? Okay, listen to me very carefully, that to reach the metal surface, electron need at least 500 joule of energy. Electron actually needs the 500 joule of energy. So obviously whenever you provide the 800 joule of energy, 500 joule will be used by the electron to reach at the metal surface. Now after reaching at the metal surface, 500 has been used by the electron. Now it is left with how much energy? Obviously 300. Okay, guys, are you getting this? That out of 800, 500 has been used by the electron to come up at the metal surface. Now it is left with 300 joule of energy, which is actually in the form of kinetic energy. Okay, so how do we get the 300? It is your 800 minus 500. Okay, 800 is your E, 500 is your phi, and this 300 is kinetic energy. This is how we got that kinetic energy should be equals to E minus phi. Have you understand that? Any confusion? Okay, only few students. Is there any student who has got any doubt? Do I need to repeat it, or can I move on? Senapati, is it clear to you? Okay, so this is how we get the kinetic energy equals to E minus phi. So now, some important points, that case 1, if E is less than phi, Tell me, is there any emission of electrons when E is less than 5? Shillong can copy after some time, after completion of this discussion. First of all, you need to answer to me. Okay, what will happen if when E is less than 5? Sinapati, you can please reply on the chat screen. Is there any emission of the electrons? Okay. So, no emission of electron. Case 2. E is equals to 5. Now, what do you say when E is equals to 5? Those who says this emission will take place can raise their hand. Those who says that emission will take place can raise their hand. Okay, 1, 2. Okay, and those who says that emission will not take place. This is E equals to 5, sorry. This is E, not E minus 5. This is E equals to 5. I am repeating the question. When E equal to 5, is there any emission of the electrons? You can raise your hand if you says yes. Okay, 1. How many of you says that no emission of electrons? Okay. And what about other guys? Those who haven't raised their hand, what are they thinking? Is there any other scenario? So guys, look at this. Think about that example which I have just gave you. That phi is the minimum energy. Let's say suppose 500 joule of energy you need to just eject the electron. At the 500 joule of energy, electron will come up at the surface. Okay. So here, actually electron is at the surface. Yes, emission will take place, but kinetic energy will be 0. That's what I mean. In the second case, electron will be at the surface of your metal, and kinetic energy would be 0 over there. Now, if I talk about case 3, E is greater than 5. Obviously, emission will take place with kinetic energy maximum. Any confusion or doubt in these 3 points? Any confusion or doubt? Okay, copy please. Then we'll move on. Okay, so let's move on, guys. Now, I'm giving you a question. Frequency of a radiation (3 × 10⁻17 Hertz) hits the metal surface, hits the metal surface, what will be maximum kinetic energy of emitted electron if threshold frequency is 4 into 10 to the power 16 hertz. Guys, please copy this once, and after that wait for some time. After copying this, we can simplify that formula as well. Okay, kinetic energy is equals to E minus phi. So first of all, let me simplify that formula, and after that you have to just put the values and you have to solve that. Okay, see, kinetic energy was equals to E minus phi. Okay, this can be written as h nu minus h nu naught. This is one of the formula. Or in the form of wavelength, you can write it as hc upon lambda minus hc upon lambda naught. Okay, so these are the simplified formula, whereas this is your work function, or you could say the threshold energy. This nu naught is threshold frequency, and this is your threshold wavelength. Copy please, and then solve that question. Copied? Okay. Do this question, tell me the answer. Is there anyone who has got the answer? Where is Nitish? Where is Nitish sitting? Is he absent today? Nitish? Okay, you are Nitish. So guys, please solve this question quickly. Tell me the answer. Senapati, have you completed that? What's the answer? Okay, who has got this answer? Minus 80. So don't think so that this answer is too short. Okay, so let me solve this question for you. Please look at the board or screen. See, kinetic energy would be equals to E minus phi. Okay, so this is your h nu minus h nu naught. Guys, look at the equation that h is common in this. So I can take h outside, and after that the equation will look like this: h nu minus nu naught. Okay, so this is 6.626 into 10 to the power minus 34. The value of nu is 3 into 10 to the power 17 and minus 4 into 10 to the power 16. So guys, what can we do? First of all, we have to take power which is common in both. See, I can write 17 as 10 to the power 16 into 10. Okay, so see, 10 to the power 16 will be common in both. So 6.626 into 10 to the power minus 34 into 10 to the power 16. Inside we will get 3 into 10 minus 4. So this is 6.626 into 10 to the power minus 34 plus 16 is what? Minus 18 into 30 minus 4, which is 26. So I don't think so that the answer you have got was right. Tell me, is it clear to you? Is it clear to everyone? Copy, please. Done? So guys, next question for you. So this is the next question. I hope so this time I'll get the right answer. That I'm giving you the data. Nu naught is 5 into 10 to the power minus plus 13. Second inverse. Nu is 1 into 10 to the power 14. Second inverse. We have to calculate the kinetic energy. This is the question asked in your AIMS 2012. Please solve this question. Nefi, can you please keep your phone and start doing something? Can you please focus on your studies? Please be in class. Senapati, are you there? Okay. Please answer the question. Okay. One answer we have got. Okay. So who is Eliza? One second. Net disconnected. Senapati, what's your answer? Okay, so who is Elsa? Eliza can raise her hand. Okay, 21. Okay. Okay, I got you. And who is Ernie? Who is Ernie? You. Then who is Nitish? Last time you have raised the hand at the time of Nitish as well. And who is Varni? Okay, absent. Who is Varni? Oh. And the Nephi, she is still busy. Have you completed that question? Oh. Okay, let me solve this question. So again, take H as a common, and here there's your 6.626 into 10 to the power minus 34. Nu minus nu naught, which is 10 to the power 14, minus 5 into 10 to the power 13. So we can take 13 as a common. Senapati, what's your answer? Take 10 to the power 13 as a common. On taking common, we'll get 10 minus 5. So this is 2. So this is 12 to 10 to the power minus 21. How my answer is different from your answer? Yet, oh, sorry. At 10 minus 5 is 5. You're absolutely right. I make it 2. Don't know why. But yeah, I did that. Okay, yeah, you are right. The answer is 33.13. Okay, so how many of you has got the right answer? Can raise their hand. Other than these 3 students. Now everyone will raise their hand. Everyone. Liar. Okay, so let's move on. Just kidding. Don't take it too seriously. Okay, so guys, that's all about your photoelectric effect. That's over. Okay, so now the next topic is the Bose atomic model. So guys, after the failure of the Rutherford atomic model, Bose given his model, and ultimately this was the extension of the Rutherford model. The points which Rutherford could not able to explain was explained by the Bose. Okay, Bose did not perform any experiment. He just tried to prove those points which is not proven by the Rutherford. That's it. So this model is actually based on few postulates. Okay, so first of all we will write its postulates. You can copy with me. First, it states that the electron revolve around the nucleus in a circular paths, and the circular paths are named as the orbits. Okay, so the first point is electron revolves around the nucleus in different circular paths having fixed energy these circular paths are known as orbits. First point, copy. Done? Copied? Senapati? Okay. Next. Number 2. Electron moves in that orbit in which its angular momentum is quantized. That is integral multiple of h upon 2 pi. This is also written like this. Okay. So guys, this is the angular momentum, which is mvr, and this is integral multiple of h upon 2 pi. N is an integer that can have positive values only. Okay, where n can have values 1, 2, 3, 4 and so on. Okay. Now the question is, what is the meaning of the quantized? How many of you know that the meaning of the quantization or quantized? Guys, do you know what is the meaning of quantized? Copy, please. Done? Okay. Guys, look at the meaning of quantization. Okay. Just understand this concept, okay? Need not to copy anything, just look at the screen. Let's say suppose this is a ladder. Okay. This is a ladder. This is a 1, 2, 3, 4. Okay. If I ask you that there is a person, okay, there is a person, this one. Okay. So obviously, if this person climbs on this ladder, what is the possibility? That he will be first on this point 1, after that on 2, then 3, and then 4. Okay. What I am trying to say, that this person cannot stand between 1 and 2. Okay. This person will either be on 1 or 2 or 3 or 4. There is no other possibility that this person can stand in air between 1 and 2. Okay. Let's say suppose this is not the possibility that this person can stay between 1 and 2. Okay. So meaning of quantization is that it has got certain fixed digits, certain fixed values. Okay. This can be a 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, and so on. Okay. It cannot have values like 1.1, 1.2, 1.3, 1.5, 1.6, 2.4, 2.7. Okay. It cannot have the values in the decimal. It will have a fixed values only the natural numbers, which is 1, 2, 3, and so on. This is the meaning of the quantization. Okay. Now, the orbital angular momentum, the orbit angular momentum, we can say, orbit angular momentum can have values like, if I put value n equal to 1, it will be what? H upon 2 pi. If I say 2, it will be what? H upon pi. If I put 3, this is your 3 H upon 2 pi. Okay, and so on. But it cannot be like 1.1 H upon 2 pi, 0.5 H upon 2 pi, 1.5 H upon 2 pi. It means that it cannot have the fractional values. Okay, it cannot have the fractional values. N cannot be fractional. This is the meaning of whole that second point. Is it clear to you? Is it clear to everyone? Say Nambati and Shillong. Okay, 1, 2, only 2 students. What about others? Do I need to repeat it? Okay. Cool, copy it. Done? Senapati in Shillong, have you copied that? Copy quickly. What's happening, guys? Shillong. Okay, so let's move on. This was the point number 2. Number 3. As long as electron moves in its orbit, it does not lose or gain any energy. If electron changes, or we can say electron jumps from one orbit to another, energy is emitted or absorbed. Okay, copy this. Guys, do you know what is the meaning of shrap? Have you heard that word, shrap? What does it mean, shrap? Have you copied that? Is there anyone who can tell me the meaning of shrap? Yes. If you won't listen to me, I'll give you sharp. Like in ancient time, it was given by the Rishi Munis. Copied? I'll simply say the Tathastu. Copied? Okay, that's good. Okay, so guys, let's discuss when energy will emitted or absorbed. See, electron is present here, which is the lower energy state. If electron goes from lower energy state to higher energy state, then energy will always be absorbed. This is your case of absorption. But whenever electron jumps from higher energy state to lower energy state, energy will always be released. Okay, so this is the scenario that if electron jumps from higher orbit to lower orbit, energy will be released, whereas if electron excites from lower energy level to higher energy level, energy will always be absorbed. Okay, see, without absorption of energy, electron cannot be excited. Okay, now this is my question to you. Why atom absorbs or emits energy? My question is, or you can simply answer me that why emission or absorption of energy takes place in an atom. Is it possible that electron can emit its energy on its own? Electron can jump from higher energy level to lower energy level on its own. Is it possible? Is my question clear to you? I'm just asking, is it possible that electron can jump from higher energy level to lower energy level on its own? Okay, someone says no. Okay, so when this phenomenon will take place? Yeah. See, absolutely right. The point is, whenever you supply energy to an atom, it first goes to its excited state, means its higher energy level. Okay. Now, in the higher energy level, electron is always unstable. Okay. And remember, guys, in the world, everyone wants to be stable. Okay. So in the higher energy state, it is highly unstable. That's why it comes back to its original state and releases the energy. Okay. So guys, remember that emission will not take place until unless absorption is not taking place over there. Okay. For the emission of the energy, there must be absorption of the energy before the emission. Okay. We don't say that electron on its own will jump from its higher energy level to lower energy level. No. To jump from higher to lower, first of all, we have to send it to the higher energy level by giving it energy. Okay. So this is the basic phenomena. I hope so it is clear to everyone that after the absorption, emission will take place. Okay. So is it clear to everyone? Any doubt about it? No. Okay, I'm giving an example. Do you know what is patake? Have you heard that? Pataka? Yeah, that's good. Okay, so during the Diwali time, I think so, that you have heard about that. Wow, Nef is very much excited. Listen to me. See, have you seen that colors after blast of that pataka? Have you seen that? Different colors, something like that. Okay, so guys, listen to me. First of all, you have to ignite that pataka. Means, first of all, you have supplied that energy to that pataka. What happened? That exactly same phenomena was taking place over there. That by supplying the heat energy, the electron goes to its higher energy state. Now, when it returns to its original orbital state, then the emission of energy takes place, which is actually seen by us. Okay, and the color we see is the concept of the complementary color that we will discuss later on. Okay, so what I am trying to say, that there is conversion of energy takes place over there. Okay, in simple words, I can say that first of all, you have given some energy to it, and after that, in return, we have got some other energy as well. Okay, so guys, what I'm trying to say is that when you supply the energy, electron goes to its higher energy state, which is highly unstable. Okay, so to get stable again, it returns to its original position, and when it returns to its original position, it releases the energy. Okay, whatever energy is taken up by the electron initially will be released by the electron when it will returns to its original state. I was saying this one. Is it now clear to everyone? Net disconnected. Okay, now is it clear to everyone? You can raise their hand. Okay. So let's move on. Point number 4. Look at this. See, this is your K shell, L, M, N. Okay, 1, 2, 3, 4. Ultimately, what I'm trying to say is, when we use the integers, we say orbits 1, 2, 3, 4, 5, and so on, and we can represent the shell by the help of letters K, L, M, and N, and so on. Okay, so the basically when n equal to 1, the designation for the shell will be K. For 2, it will be L. For 3, it will be M. For 4, it will be N. 5, O, and so on. Okay, these are simple alphabets. K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay? Copy, please. Copied. So let's move on. Number 5. The change in energy. When electron jumps from one energy level to another energy level can be written like this: E2 minus E1. Okay, bigger minus smaller. This is the point number 5. Okay, and after that, applications of Bohr's atomic model. Means there are few important results on which we have to deal few questions as well. Okay, which is very much important with respect to your examinations. Okay, so we need not to drive all those relations. Okay, that is not the part of our syllabus. We have to just remember those formulas. Okay, so let's begin. See, and first of all, guys, so you have to remember one thing, that let's say suppose this is the electron. Okay, this electron excuse me, is feeling actually two type of forces. Okay, one is your electrostatic force, which is inwards. Number 2, centrifugal force. Which is acting outwards. Did you remember that Rutherford could not able to explain why this electron is not collapsing with the nucleus? This is moving in its path. Okay, it is not going into the nucleus. So actually Bohr said that actually there are two opposite forces are acting exactly on the electron, electrostatic force and the centrifugal force, and these are balancing each other. Okay, So so due to that balance, the electron won't go inside the nucleus. It won't collapse. Okay. So it will move in its orbit just by balancing these forces, just because of these balanced forces. Okay. So you have to remember that here electrostatic force is balanced by centrifugal force. I think so that you have already covered in your physics syllabus. Okay. Electrostatic force and the centrifugal force. Please copy this. Done? Senapati, have you copied that? So guys, let's move on. Let's see its important results. First, radius of nth orbit. And the radius of nth orbit is Rn is equals to 0.529 n square by z angstrom. First formula. Second, velocity of moving electron is 2.18 into 10 to the power 6 z upon n meter per second. Where z is your atomic number and n is the orbit. Z is your atomic number, n is your orbit. Copy please. Copied. Okay, so let's move on. Guys, you have to remember these formulas. Next. Number 3, if we talk about energy of stationary orbit, which means that orbit in which electron is moving. Electron is not changing its states, it is moving on its orbit. Now, there are two types of energies working over here. First is your kinetic energy and second is your potential energy. Okay? So, kinetic energy is equals to half of K Z E square by R. Guys, this K is 1 upon 4 pi epsilon naught that you have studied in electrostatics. Okay? Potential energy is minus K Z E square by R. Guys, again, I'm telling you have to remember these formulas. Okay? So, when we talk about the total energy, TE stands for the total energy, which is equals to kinetic energy plus potential energy. Results, we have to just remember the results. Okay. Now, on adding these two, we will get total energy is equals to half of kz e square by r minus kz e square upon r. On solving it, we will get total energy is equals to minus half of kz e square by r. Remember these formulas. Copy, please. Okay. 1 minute. Then let's move on. So, finally, the formula of total energy is minus 2.18 after putting all the constants over there, minus 18 z square by n square joule per atom. Okay. Most of the time you will find the energy in the electron volts as well, another unit of the energy. So in that case you will directly use this formula. This is your minus 13.6 z square upon n square electron volt per atom. These are your final required formulas that you have to remember. Okay. And one more important thing that you have to remember, that ratio of kinetic energy to potential energy to total energy. We have to just put those formulas over there, that kinetic energy was equals to half of k z e square by r. Potential energy was minus half of z k z e square by r, whereas this total energy was minus half of k z e square by r. So everything will get cancelled out. Okay. After the cancellation, we will get the final results. On solving this totally, we will get 1 is to minus 2 is to minus 1. Okay. So this is the ratio of the kinetic energy to the total energy to the, kinetic energy to the potential energy to the total energy. That you have to remember. Copied? Okay. So, guys, I'm giving you a question. Please solve this question. That if total energy of an electron is minus 1.51 electron volt, in hydrogen atom, then find out kinetic energy, potential energy, and orbit. Please solve this. Nefi, what's going on? You're still talking. Guys, will you be able to solve all that sheet which is given by me of redox reactions by the next week, so that I can arrange a doubt session for that one? Okay. So, I'll inform you on the group that on which day we'll discuss the doubts of the redox reactions. Okay. I hope so that you are solving that sheet. Okay. Please solve this question. Tell me the answer. Senapati, have you solved that? K is a constant, which is 1 upon 4 pi epsilon naught. E is the charge on electron. Okay. You have to just remember that formula only. Okay. Other than that, these are the final formulas that we have to ultimately use. Just put the values and solve it. But I think so in this question, this formula cannot be directly used. Guys, see, we have just seen that kinetic energy is equals to half of kz e square upon r, whereas potential energy was equals to minus half of kz e square by r. If I put these into the ratios, this will get cancelled out and I'll get a relation between kinetic energy and the potential energy. See, I have already given this relation to you. Look at this. If you don't want to use it, you can derive by using this phenomena. Okay, so we will get that kinetic energy upon potential energy equal to half. Kinetic energy upon potential energy is equals to what? 1 by 2. Okay, this is one of the relation. We have given with the total energy. We know that the total energy, that was the previous relation, the total energy was equals to half of kz e square by r, and potential energy was equals to minus, this with the sign minus, kz e square by r. Divide these two. This will get cancelled out. We will get a relation, total energy upon potential energy equals to what? 1 by 2. Total energy is given to us, which is 1.51 into 2. This is how we will calculate the potential energy. If we have got the potential energy then we can simply put this one into this relation and we will get the kinetic energy as well. Is it clear to you? How many of you has got this one? Shillong? Okay, one. Please solve this. Yeah, here it is minus 1 by 2. Here it is minus 1 by 2. Here it is 1 by 2. Okay. And the potential energy along with the negative sign we will get 2, 0, 3.2 electron volts, 3.02 electron volts. What about other answer? What will be the kinetic energy? Okay, very good. This is the answer for the kinetic energy. Is minus 1.51 electron volt. Any confusion or doubt in this question? Shillong, Senapati? Is it clear to you guys? And what will be the value of n? What will be the value of n? Okay. Kinetic energy is plus 1.51. What will be the value of n? Have you calculated the n? See, energy is equals to what? Minus 13.6 z square by n square. Okay. E is given to us minus 1.51 minus 13.6. Z will be 1 for hydrogen and we have to calculate. So n square would be equals to 13.6 upon 1.51. So on solving this, we will get a result. Copy please. This comes out to be approximately 9. Okay, so n will comes out to be 3. This is not exact 9, this is approximately 9. Okay, so you will get the 3 as your result. Any confusion or doubt in this question? Okay, so we can move on. So next question for you guys. Calculate the ratio of radius of Bohr's second orbit to third orbit in hydrogen atom. Tell me the answer. What will be the answer for this one? Answer okay. Let's see. We know that radius is equals to 0.529 n square by z. Okay. So it is hydrogen atom. So we can say it is proportional to n square only. Okay. So we have to calculate R2 upon R3, which is what? 2 upon 3 whole square. 419. Copy. Any confusion or doubt? In this one, any confusion or doubt? Okay. Next. Calculate ratio of radius of Bohr's third orbit of He plus ion to second orbit of Li2 plus ion. Tell me the answer. Hey guys, you need a break? Anyone who needs a break? Okay, just 15 minutes. After that, I'll give you a break of 4 to 5 days. So relax. Tell me the answer. Is there anyone who has got the answer? Guys, what are you doing? Same solving this question. Rn is proportional to n square by z. Actually, in the previous question, z was same. That was, we were talking about the hydrogen atom only. Okay. Yeah, might be this is the answer. Let me check. N1, sorry, just take it n and z. Okay. So we have to calculate R3 to R2. So this is what? N3 square. Yeah, this is the N3 square upon Z3 into Z3. One second. Z2 into N2 square. Okay. You can simply put the values in this formula. Okay. On putting the values, see, this is 3 square 9. Yeah, I'm putting the values. Helium has got atomic number 2. So this is into 2. Next is the lithium, second orbit. 2 2s are 4. And lithium is 3. Formula is n square by z. Oh, wait. N square by z. Shit. So this is your N2 square and this is your Z2. Okay, that's the point. Reverse these values. 3 upon 4. 2 is 27 by 8. So this is the ratio, R3 to R2. Any confusion or doubt? Can you move on? So guys, our next question for you. That calculate the energy of first, second, third, and fourth Bohr's orbit of hydrogen atom in electron volt. Do this question. Senapati, are you there? Just attempt this question, then I'm writing the answer, then you have to just check. Oh. Have you got these answers? Have you got these answers? Okay. Only one has got this answer. What about others? Okay, two. Okay, so many has got these answers. Those who haven't got the answer, please copy this. Guys, are you understanding that how we are putting the values in the formulas and we are calculating the results? These, see, in the examination point of view, from the examination point of view, this is very much important. There is probability, very high probability, that you will get question from this one, from Bohr's atomic model. Are you getting this? Okay. Next question. If energy of first orbit of hydrogen atom is X, then what will be energy of Bohr's third orbit of hydrogen atom? Attempt, please. 2 minutes for this question and then we will discuss about it. Oh, you can write this X electron volt. X electron volt. Done? Is there anyone who had done this question? Can I start? Or you need some more time? Okay, 2 minutes. 2 minutes more for this question. Okay, let's see. Okay, oh, so guys, let's start. First of all, remember one thing, that if energy of one orbit is given to you, then we have to use this one. That E1 will be what? That constant, take it as a R, okay? Z1 square upon N2 square, and E2 would be what? RH Z2 square upon N2 square. 1 second. E2 would be what? RH with negative sign, Z2 square upon N2 square. Just divide them and you will get a ratio that E1 upon E2 would be equals to Z1 upon N1 square into N2 upon Z2 square. Remember this relation as well. This relation will be used whenever in the one condition you have given with the energy and second energy is asked to you. Okay? So guys, remember one thing, that the first energy is given to you X. Okay? You have no information regarding regarding that given value, that X can be anything. Okay? So if I put that value over here, this is your X. E2 you have to calculate will be equals to what? Z1 upon N1. So Z is 1 for hydrogen. That was the first orbit. This is square into, we have given with the third orbit, which is N2 upon Z2. So 3 square upon 1 square. So E2 would be actually equals to X upon 9 electron volts. Is it clear to you? That you have to calculate in terms of X. Now X can be anything. Okay? How many of you has got this concept? How many of you? Copy please. Those student who has got this one, please raise your hand. And those who wants me to repeat it again can. Okay. So I'm repeating the sentence. Those who don't want me to repeat it can raise their hand. Okay. And what about others? They wants me to repeat it. Okay, that's good. I have seen some symbols like this as well. Okay, so guys, this is your Bohr's atomic model. Okay. We have discussed all its postulates, all its important applications. We have to discuss about the emission and the absorption spectra that we will discuss in the next class. But before that, we have to discuss few important terms as well and some other questions based on the Bohr's atomic model. So remember one thing, that in the next class, everybody will make sure they will learn all these formulas. Okay. So that we can practice few more questions. Okay. So guys, that's all about for today's session. Finally over. So now you can go. So bye-bye. Take care. Have a great time. See you next time. Bye-bye.